Hi, Tomáš is here making another programming drill. This will be about floating points and it will be practical one followed by theoretical one. So we will have here some tasks. The first few tasks are very simple, just about basic technique of comparison between these numbers correctly. We should distinguish whether numbers are equals, which number is higher. In this case, equality does not matter, we just want to print the higher number. Here is the case, but actually we have to think about equality and how to work with some epsilon there. Then we have sailing, flooring. There also we should approach the error in different way. Number is in the interval, and this is, so we will process these. And this is actually it's not complicated program, but it's kinda complete. It's already some task actually, and we will have to use some technique to manage it correctly. So let's start with that. So we're having some tasks. So let's just create files, task, and let's use, so we're having 7 files. One line is awesome, isn't it? I already have here some code, so I can start with this. This isn't necessary here. As we can see, we will use our alias. As we can see, this works wrong. Why this works wrong? Because numbers are not precise. Look at it. As my text editor is showing me the value here, and we see that point 1 is slightly higher than it should be. And the same thing applies for point 2, and point 3 is slightly different also. It's when we have this in our editor, I think, let's see, just for interest, how it looks in float. So you can see that in float, error is much higher. Okay, so but we are not using float, and we want to compare this correctly. Okay, so how to approach this problem? Let me bring some drawing here. So this is this is numeric axis, and here is point A, here is A, here is B. This is A, this is B, and what we are interested in is this distance between A and B. And the distance is actually its difference. So difference between those two numbers is basically A minus B or B minus A. And the absolute value from that is the distance between those two numbers. So we have this distance between those two numbers, and we will compare this whether it's smaller than some tolerance. Yeah, so this is our plan. This is our plan how we will approach this problem. Okay, so what I need for that? I need absolute value. For absolute value, I need include mark.h. So a minus b is the distance between those numbers, and now the tolerance. Yeah. So we will name it epsilon. And how to define epsilon? We have a couple of choices, like define epsilon e minus 12, and now it should be, yeah, this is pretty good epsilon. If you want to use double epsilon, then do it like this. Include float.h, and instead of value here, just type something like 1000 times double epsilon, and this is also okay. Yeah, but this still isn't correct. This would be just this focusing on absolute error, but those numbers can scale really crazy. So in this example, this is going to be working. But when we have made these numbers very huge, so now these numbers are really huge, and epsilon is just a small number, and this epsilon basically means nothing to compare to these numbers and their difference. So in this case, it will be always difference. And when we have from other side, when we have small numbers, and we will do incorrect numbers, so it shouldn't be equal never. This will be equals because those numbers are too small, so also a difference between those numbers is too small, and the epsilon from this point of view is a gigantic number. It's some crazy big number. So to improve this, we should just simply scale the epsilon by one of these numbers. It doesn't matter which one, but make sure that your epsilon will never be negative, because the difference couldn't be negative on this side. We can have distance between negative numbers as well. So for example, a can be negative, and I have to scale epsilon, so it will still be positive number. So something like this, and this will be working for every case. What is it per month? Yeah. Yeah, I broke that. So this is difference, and this is right. When we do these numbers, it's as you can see, it's working right. Huge numbers. It's working well as for huge numbers. And if I screw it, should be detected that is different. Yeah. Yeah. So this is how you do. This is how you do that. We will come to this example later on. Okay, second task. Yeah, let's make it Let's make this or organize this. So second tab, print out the high number. Yeah. I choose this example because it is showing you how you have to think about these numbers. If we want just print out higher number, we actually doesn't care which we want just a higher number, and we actually doesn't care if numbers are equal or very close to each other. So yeah, let's use this to start our code, and if you want to just pick a higher number, we can compare it normally. V is higher and is higher. If you want to compile task to V is higher. Edit this. When we rid of this scaling, now A should be higher. Yeah, this is kind of interesting how these numbers working. Okay, so how to check when equality does matter, and so let's use this. And so we want to check that A is smaller than B, but not equal. And it will be a bit tricky. You have to think about that. You have to think about that. Yeah, it will be also the task. Yeah. Okay, so A is smaller than B, but not equal, and it's a difference. It's different than this one, because this condition is satisfied when A is smaller than B, but let's say that A can be like smaller, but not too much, right? Because we should. Let me also bring another drawing here. So we will keep here A and B. Yeah. So we will choose just one of these numbers, like A for example, and we will put here some tolerance. So let's use another color for this, and let's say that from here to here we should make a circle. Oh. It's terrible. Circle. Yeah. Oh. Okay. Yeah, nice. Yeah, so this. Yeah, at this point here is like A minus epsilon, and this point is A plus epsilon. And when b is in this range, we can consider then that those numbers are equal, because this epsilon is our tolerance. And the same thing we should also consider here. So so it should be a should be smaller but not equal. So we should obviously put epsilon on one of the sides, like let's say to a, and the question is, should we subtract the epsilon or add the epsilon? Should I do plus epsilon or minus here? Plus or minus here? That's a question. So let's think about that. This condition is happy when a is smaller than b. If I add epsilon here, I'm giving some disadvantage to this condition. Like this a wants to be smaller than b, but here is on some other load which will make it for our a harder, right? So this is so this should be right. This should be right. A plus epsilon smaller than b. It prevents them from equal. This logic can be sometimes hard to imagine in your head, and you have to think about it. You have to be precise here. I have also the technique which is straightforward, and you don't have to think so deeply about that. So what we can else do? Like this is right. This is one solution. And then we have to think it. Another solution is a is smaller than e, a is smaller than b, and is not equal, right? So abs a minus b and greater than epsilon times abs. And so I'm bringing here this condition, but also I want the distance between those two numbers is greater than epsilon, so they are not equal. This is negation of our equal condition. Okay, so let's try to approach this. Okay. I hope this is easy to understand. Let's try it. A is higher. Is it true? Yeah, those numbers are slightly higher than should be, and this is slightly smaller than should be. Yeah, A is higher. That's right. And also, this epsilon, I forgot to scale this one. So times previous A. Yeah, this was a bit of a mistake here. Okay, so A is smaller or equal to B, so we can make trick like A. But now we want to give some advantage to the condition, so minus epsilon, which helps A to be smaller. A and smaller than b. Yeah. And actually, this technique, actually, when we have this, I thought that I will return to this. When we have this condition, we can also mathematically it means something like this. A minus epsilon is smaller than b, and b is smaller than a plus epsilon. This is expanded version of this absolute value here. Of course, I should scale the epsilon there like this. This is actually expanded version of that. And we are checking the b from both sides, whether it's in some interval. Also, we can here use some math, can we? There is an absolute u, yeah, and so this simply means like a is smaller or equal to b, and b is smaller or equal to a, which obviously means that a is equal to b. So this is the math behind this. If you don't like absolute values and counting with them, just simply this is just simply expanded, condensed this. Yeah. Okay. I think we don't have to write all other variants, because obviously, like a is smaller than b, negation is that a is greater or equal to b. So basically, when we have just this one, we can oh, okay, I deleted. Yeah, I deleted what was right here. So but what I want to say is, when we have a smaller than b, then negation is a is greater than b. So basically, when we do just negation of those two, so we will just change here b and b to a. Teď nemůžu. Teď nemůžu. Jo, děkuji. So when we just swap these variables, like instead of a we write b and etc., it will be the same. So we don't have to continue to make all these. The main goal was successful. Okay, so now task 4. Not in this window. Task 4, let's bring here some code we will start with. Okay, so So this is about the ceiling, flooring, and truncate, many tiles. Yeah, so we have some path. Do some path and front. Upland, and we have some tile. Okay, so we can scan it from input. When we want to scan it here, we use percentage LF. We expecting 2, and yeah, that's validated. Yeah, I forgot to put here these parameters, so path length and tile length, path length smaller than 0. So yeah, so we have validated. And now, yeah, of course, we want to divide path length by tile length. So let's do like number. I don't know how to name the variable. So like, let's name it like division, for example. And now we have this division. Percentage L, so percentage of division, and let's print it. So for now, okay, so let's put here some input. Let's say, I don't know, like 20 and 2.2. New line would be nice, right? Yeah, good. Yeah, so we are obviously getting some part of tile, some incomplete tile, and we can have a task to sail to count this one also. We can have a task to count, to round it basically down or up. So let's see if the approaches. That percentage so the answer to task A, and here we want to seal. We need to count last incomplete tile as a whole number. Okay, so we need to seal div does the we do not want, so for yeah. Yeah, so something like this. something like this. But here can be a problem when actually the number is very close to very close to like some whole number. Like for example, when we have slightly less than 5, but it should be actually 5. It's slightly less because of error in these numbers. And here we have to put the epsilon. This is sailing, and here we should always subtract epsilon. Epsilon, because and here we should add epsilon. This epsilon we don't want to scale actually, because look at this, how scale is working. It will round to nearest higher integer, right? And these numbers, as I said, it could be like a huge numbers, like extremely huge numbers, also extremely small numbers. But in this case, we just interested about nearest integers in these, so we don't want ever our epsilon would be like 10 million, for example, because it doesn't make sense putting this in the sale, right? And also you can send it like when we have like those two numbers, they could be like both can be small, both can be high. When they divide each other, it normalizes to some normal number. So there is another sign which is helping us that epsilon should not be scaled here. Okay, so this is the task. Yeah, let's try some number. I'm not sure if I can this break from this point of working. Let me try 42 and 7, 6. Yeah. So this is the case when we break it. We made it counting for 6. And it's 6. It should be 6. It should be every time 6. But the sail here did 7, and the floor did 6. So, and pretty much always when it doesn't hit exactly the integer, it would fail. So this is why. So yeah, let's fix it again. And now it's okay. Okay? So fix it like that. Okay, let's allow these numbers. There. Yeah, okay, so here we go. Take off this validation. And the problem here is in this example it's not a problem, but let's do something else. Let's do this. And now it's kind of a problem. You can see that sale, it should give us like the whole number, which is higher. And it is actually higher, and you can see the behavior that sale is actually, it will pick the nearest higher integer, but when it's negative number, so we have like 8.7, the sale will be to 8, and the floor will go to the small number, which we don't want here. We want here to make something like something else. Sure. So how we can approach this? Yeah. So then we have to ask if this is like if diff is negative. So when diff is when diff is positive, we will do this. Otherwise, we will swap the behavior. So we will use instead of A, we will use floor instead of sale, and in B we will use sale instead of floor. And now, if sum of number is negative, we having expected same behavior as before. Okay. There is also something like truncate, which is similar to floor, but it behaves it just it will just get rid of this fraction part, this way. So we can use it instead of floor. We can use truncate. Truncate. In this case, this is the case, and we can use truncate. Yeah. As you can see, it's to the same. Yeah. Okay, so this was this fifth thing. Then we have numbers in interval. Okay, how to approach this? I think we can do just some maybe just some discussion. It's kind of similar than this technique. This is actually interval, right? So let's start with this code, and we will do it really quickly. So number is an interval, and exclusive means that boundaries of interval are not counted. So let's do that. So let us have interval I don't want to use names ABC. So let's use from to and number. And some number. So the number is exclusive. So we have a couple of approaches here. We can compute the center of interval and the distance from the center, which would be condensed like this to just one condition. Or we can check each side separately. So let's do each side separately. So number is an interval. So number smaller than from, and this is exclusive, so it means number smaller, exclusive than, but not equal from. No, what I'm doing, number should be greater than from, but not equal, so it means that we want here some disadvantage. So we will add to the number from epsilon times and at the same time number minus epsilon number 9 minus epsilon is smaller than 2. So smaller than 2, yeah. Yeah, so this should be excluded. In this case, like technically, if I would do it just simply without any epsilons, this number would be in the interval. So let's see if in our example is not. So let's get rid of input and it's task 5. Number is an interval. It's wrong actually. Okay, so which side of our interval is wrong? From 2. Yeah, I forgot to scale the epsilon, but I don't think this is the problem here. Number is smaller than 2. Oh, I see it. We are actually, it's greater than 2. It's greater. We are actually helping here the condition to be happy. So actually swap these signs. This condition wants that number proceed to be smaller, to be greater than variable from, and so when I subtract something from number, I will make it harder for number to proceed, which is that what we want here. We want exclusive interval. So let's I guess now it's okay. If we do some different number, it's out of interval. Yeah, it's still out. And do some number which is in. Yeah, so this seems to be right, I would say. Okay, then we want number is an interval and it's inclusive. So we are including both sides of interval as a values. in this case, you just swap these signs. So instead of, let's select number now could be greater or equal, and smaller or equal to 2. This is now, yeah. So this should be still in the interval. It is in the interval, and this should work as well. This should be also in the interval. It is in the interval, but in previous task it wasn't. Yeah, okay, so we are having these basic tasks, all of them. How long are we doing? 45 minutes, oh my god. Okay, so let's stop the video here, and the last task will be in separated video. So